Hello, I'm going to show you how to build a production-ready microservice platform using Docker. In this project, we are not just running containers. We are designing a system that reflects how real-world applications work. We will use Node.js microservice, an NGINX Gateway, and a zero-trust architecture. The main goal is to understand how services communicate securely inside a system, not just how to run them. This is not just a demo. This is how modern backend systems are designed. Traditional development problem. Before we build the solution, let's look at common problems beginners often face. First, many people expose to many services through the public. This creates zero security risk. Second, they use hardcore IP addresses, which makes the system fragile and hard to scale. Third, there is no isolation between services. If one service fails, it can affect everything else. And finally, scaling becomes very difficult because everything is tightly coupled. Most beginners treat Docker like a simple tool, but in reality, it should be used as a platform. Solution. To solve this problem, we use a microservice architecture. Each service is independent, isolated, communicating through a private network. We introduce a gateway as the single entry point. This means all external traffic goes through one place. Internal services are hidden. We also apply a zero-trust model, where no service is trusted by default. Every service is private unless explicitly exposed. Architecture. Let's look at the architecture. The client sends a request to the host on port 8080. Docker then forwards this request through the gateway container. Inside Docker, we have a bridge network where all services communicate. We have three services: Auth Service, Product Service, Auth Service. The key idea here is simple. Only the gateway is public. All services communicate using service name via Docker DNS. This creates a clean and secure system design. Project structure. Our service is organized in a clean and scalable way. Each service has its R folder: Auth Service, Product Service, Auth Service. We also have a gateway folder and a Docker Compose file. This structure allows independent development, easy scaling, clear separation of responsibility. Each service can be deployed or updated without affecting others. Docker Compose. Docker Compose is the core of this system. We define service networks dependencies. One of the more important parts is the bridge network. This creates a private network where containers can talk to each other. Docker provides built-in DNS. We also use depend on with health check to ensure service start in the correct order. This is how we simulate a real production environment. Gateway. The gateway is the entry point of the system. We use engine to route requests /auth point auth service /product point product service and /others point other service. The gateway acts like an API gateway in real-world system. It is responsible for routing, security, traffic control. Clients never talk directly to internal services. Auth Service. The Auth Service represents the authentication layer. It provides endpoint line, /help, and /login. Even though it is simple, it plays a critical role. In real system, this could handle JWT, seasons, and user validation. Product system. A product service. The product service returns product data. It is stateless, meaning no store season, easy to scale horizontally. This is ideal for cloud environment. Auth Service. This is where things get interesting. The Auth Service needs to call another service. Notice no API errors, only service name. This works because of Docker DNS. This is real microservice communication, dynamic and decoupled. Internal networking. Docker provides two key features: DNS resolution and network isolation. Each service can call another using its name as a hostname. This works because Docker automatically maps name to IPs. Service name is the hostname. Let's review the flow of project.